All right, so today we're going to know about conduction, radiation. I think you should be able to see it all on your screen. Conduction, radiation is the three ways heat can be transferred. Three ways heat can be transferred are conduction, radiation. Thermal energy, once again, heat flows from warmer to cool. Okay, warmer to cool. It does not flow from cold to hot unless work is involved. So in this, okay, a couple different things. The soup is heated in the pan by convection. The hot soup rises. The cool soup falls to the bottom to take the hot soup's place. The pan is heated by conduction. Okay, it's transferred to the pan by conduction. And the pan is an insulator, otherwise you will burn your hand. So three ways. Typically, when I think of this, I like to think of convection is something occurring typically in a liquid. Conduction is occurring something in a solid, and radiation, which occurs in a gas. Radiation, okay. Conduction. So I'm talking about conduction. About conduction, we're talking about things that are in contact. Okay. Conduction has to have the heat transfer. Conduction has to have particles in contact. That's why it typically occurs in a solid, because we know that in a solid the particles are very close to each other. So like when you're looking at this, this food is touching the water. Okay, so that would be the conduction. All the little particles in the bottom of this frying pan. Okay, all the bottom, they're very close to each other. They're vibrating and they're turning heat from one thing to another. So if you have ever touched a metal spoon sitting in a pan boiling, be surprised to be how hot it is. Okay, think what you know about metals and non-metals. What do you know about metals? Metals are what? No, metals aren't liquid filled areas. I mean, only one is. But what do you know about metals? They're conductors, aren't they? I mean, the wire in your house, for electricity, all that stuff is typically, you have to have a physical wire. That's like one of the biggest things, when the new iPhones came out, and you had the wireless charging, okay, was a big thing. Because typically, even some of the electricity, you had to have a metal in there. You had to have it connected to be able to charge. So, why is the metal spoon hot? Is because of conduction, okay? And you can see in this picture, it very much explains all of this, okay? Radiation would be the heat leaving the gas, okay? The conduction is because anything that is touched to the metal is vibrated. Any continuous piece of metal, the particles are very close together, so the heat's transferred through those vibrations, okay? Convection's occurring in the water of the boiling pot. You know that hot air rises, correct? And cold air sinks, okay? We know that warm water has a lower density than than cool water. So we know that the more dense, it sinks. A prime example of conduction would be you cook a hamburger on the grill, you forget your cheese. You take the hamburger off the grill, you go put your cheese on the bun. Does the cheese melt? Yeah. Yes, okay. The cheese melts. Okay. Now, if you put the bun on top of it, is it going to melt better as opposed to just by itself? No. Yes. The more things you have in contact, the better it's going to melt. So I think like a grilled cheese. Who likes to make a grilled cheese? Oh, we all like grilled cheese. What's the matter with you?
Oh, yeah, I like grilled cheese.
Why does your cheese melt? Okay. Why does your cheese melt? Does your cheese melt better if you have two pieces of bread on it or just one piece? Does your cheese melt better if you have two pieces of bread on it or just one piece? Two pieces. Because you have more things in contact. It keeps the heat in there. Convection, okay, is the movement that transfers heat through fluids and air, but it's typically just through fluids. Okay, heat is transferred through it. So we kind of already talked about this. Conduction would be like your air. Convection would be like your air vents. Okay, convection would be like your air vents. Do we have an air vent going on right now that I need to turn off because there's a lot of heat in here? I'm hot. Okay, I'm gonna turn it off. I'll turn it off after y'all's class period. But your air in your house is typically convection. Does anybody have radiators in their house?
Yeah, the radiator. I really got a radiator in your car.
I hope every car has a radiator in the car. But when I grew up, we had radiators in our house, and I used to love them. Okay, so I can go sit in a radiator. It's kind of something like that. Water flows through it. Okay, water flows through it, and that's how they get the heat. Okay, and you have to have a radiator in every room. You don't have like the air ducts outlets that you see. Then I can go sit my clothes on it in the morning and be very warm. I can't really sit my clothes on top of a vent. If I put my clothes on top of the vent, it's just going to block the vent, correct? Interesting fact about this school, we're talking about convection, talking about air vents. Y'all know how the heat works in the school and the air works in the school? In an inside classroom, when you go to an inside classroom, I want you to look at the ceiling. Look at the ceiling, you're gonna notice every other hole of tiles has every other row of tiles has little tiny holes poked in. Mine does not, because I have a heater and air conditioner in here. And the heat comes, or the air comes through there. You think that's very efficient?
Nope.
When's the last time you think that, that's why you see like classes, they poke the big tiles out, okay? But that's how they get the heat through there. Well, how much dirt do you think, and dust do you think's up there blocking those holes? A lot. So, convection typically occurs in liquids. The biggest thing when you hear about convection currents when you're talking about the ocean, okay, has a lot of things to do with hurricanes and where hurricanes go. Hurricanes generally hit the same places, don't they? They generally hit the same places, don't they? More hurricanes hit like Louisiana, Mississippi, Florida, Texas than they do like South and North Carolina, don't they? That's because the convection currents that are in the ocean, okay, they drive the things there. What's up? Yes, sir. I have some tissue somewhere too. So examples of convection, okay, air movement in a home. Right now, does anybody have a 2-story house that they live in? What's cooler? What's warmer? You upstairs or you downstairs?
I got one.
No. Upstairs. Upstairs warmer because hot air rises, okay? That is convection. Hot air rising is convection, okay? It is convection. Radiation is the transfer by waves, by electromagnetic waves. Transfer by it does not require matter, okay? It does not require matter. Typically, when you think of radiation, you think of the sunlight, okay? Light is typically our main form of radiation. Like I said, you can cook a marshmallow by radiation. You can cook a marshmallow by radiation. You're not going to, I would cook it more by convection because I'm going to stick my marshmallow on the fire, but you can stick it above it and you can stick it above it and it'll cook it by radiation. So 3 examples of radiation, typically anything with light. Anything with light would be examples of radiation. So the 3 ways heat are transferred are conduction, convection, and radiation. Okay, so that's all I got for you today. And you have a writing assignment. You have a writing assignment talking